Hey guys, Physics in the Flesh is back with another non-uniform circular motion problem. A particle revolves in a horizontal circle of 3.00 meters. At a particular instant, its acceleration is 1.06 meters per second squared in a direction that makes an angle of 31.0 degrees to its direction of motion. A. Determine its speed at this moment. And B. Determine its speed 2.00 seconds later, assuming constant tangential acceleration. So first things first, I'm going to draw a diagram. Okay, I'm dealing with a horizontal circle, but of course when I draw it here, it's going to look vertical. But just keep in mind, it's a horizontal circle. Okay, so here's my circle. Okay, so there it is. I've got a ball revolving, or a particle. This has a radius of 3 meters. R is equal to 3.00 meters. Let's see. At a particular instant, its acceleration is 1.06 meter per second squared. Now, because this is non-uniform circular motion, remember acceleration is comprised of the centripetal part, or the radial part, and the tangential part. Those two combined together give you the total acceleration, which is 1.06. Now, the total acceleration, well, here's the direction of motion for this particle. Particle at an instant is trying to go tangential to the circle. Okay, and it tells us in the question that its acceleration, the total acceleration, is in a direction that makes an angle of 31 degrees to its direction of motion. Therefore, the total acceleration is probably going something like that. Okay, so therefore the angle in between here, that's your 31 degrees, 31.0. So we just said that this arrow right here represents the total acceleration, so we'll just call that A. Now, you see this arrow that I drew, this is its direction of motion. That arrow can also be a vector representing the tangential acceleration, because after all, it's tangent to the circle. Okay, so we've got AT here. And as we learned in previous videos, centripetal or radial acceleration goes towards the center of the circle. So there's my last part, A centripetal. So you've got all your components there, and they add up to give you A. Now, theta we'll call 31 degrees. Okay, so that'll be our theta. I've got another angle here. I'm going to call that one alpha, okay? Now, alpha and theta together make 90 degrees. Okay, so pretty much what you've got here is you've got 35, or 31 rather. And so the missing angle here is going to be 90 minus 31, which is 59 degrees. Okay, so there you go. Now, how do we solve this problem? Determine its speed at that moment. Okay, well, we're going to figure out speed using the centripetal acceleration. Okay, centripetal acceleration is v squared over r. We know that the total acceleration is 1.06 meters per second squared. Now, how do we get the centripetal based on the total? So take a look at this, okay? So if you made a right angle triangle out of these two vectors, right? If we extend that a little bit, if you make a right angle triangle there, with that being A, then this is the hypotenuse of your right angle triangle, your acceleration. So if you do acceleration times cosine of alpha, you're going to get centripetal acceleration. Okay, so A centripetal is equal to A cosine alpha. So 1.06 meters per second squared, cosine of 59 degrees. Plug that in and you're going to get centripetal acceleration is 0.55 meters per second squared. And again, we did that because we know centripetal acceleration is equal to the square of the speed divided by radius. So you take that number and you set it equal to v squared over r. And let's solve for v. So multiply both sides by r. So v is equal to square root of 0.55 meters per second squared times r, which is 3.00 meters. So let's put a capital R there. Okay, so plug that in, take the square root, and you're going to end up with v equals 1.28 meters per second. Okay, so there's the speed at that moment. Okay, at the moment where the acceleration is 1.06 meter per second squared. Okay, so there we have it. So part A is done. Part B says determine its speed 2 seconds later, assuming constant tangential acceleration. Okay, so part B has to do with something like this. if you've got constant tangential acceleration, remember in a circle, for non-uniform circular motion, yes, you have tangential, you have centripetal. Centripetal's only way that it's changing the velocity is through changing the direction. Okay, the speed's remaining constant. What tangential does is it changes the speed. Okay, so if you've got tangential, the speed's actually changing as you move in a circle. Okay, which technically it's not exactly a perfect circle anymore necessarily. Okay, so here we go. Determine its speed 2 seconds later. So if it's 2 seconds later from this point, that means the initial speed is this. What we just found out. V naught is 1.28 meters per second. Okay, we're looking for the speed after 2 seconds. So t is equal to 2.0 seconds, assuming constant tangential acceleration. So let's find out what this is. Okay, we're going to do the same thing. We're going to use our triangle. Okay, if you take a look at the diagram, tangential acceleration is adjacent to the angle theta inside. Okay, so if you do A cosine theta, you're going to get tangential acceleration. Okay, so AT is equal to A cos theta, which is equal to 1.06 meters per second squared, cosine 31.0 degrees. And when you plug that in, you're going to get A tangential is 0.909 meters per second squared. Okay, so now we've got tangential acceleration, time, initial speed, and hence we can find final speed. Okay, and we're going to use the really straightforward relationship, or rather the definition of acceleration, which is acceleration is equal to the change in speed, v final minus v initial over time. That's it. Okay, and all we have to do is isolate for your v here. So multiply both sides by t, add v naught to both sides, and you're home free. So v is equal to v naught plus at. Okay, some people memorize this formula. Honestly, just remember that acceleration is change in speed over time, or change in velocity over time. Plug in your values. Okay, so v naught, 1.28 meters per second, plus, this is tangential acceleration, so plus 0.909 meters per second squared, times time, 2 seconds elapses. Plug that in your calculator, you're going to get v equals 3.10 meters per second. Okay, so there's the speed 2 seconds later. So notice in the beginning we had a speed of 1.28 meters per second. We ended off, after some more time, your speed actually more than doubled. Okay, and that's the role of tangential acceleration. So that's it for this video, guys. Be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from yours truly. Be sure to be on my channel at 12 noon every weekday so you can catch my latest video. See you guys tomorrow.